2-second win.
Okay, listen. All right, quiet down. Hey. Okay, so we're going to do some derivatives. I got down to that every time. Okay. Of some trig functions. Derivatives of some trig functions. They didn't like that title in the last class, but
I don't like the sound of it.
Wow, for you guys. I think it sounds great.
It sounds hard.
Nothing like your
Of derivatives of some trig functions.
the derivative. Now, listen, I'm not going to get too deep. I'm not going to get deep at all into how these are figured out. But I'm going to just give them to you now, the ones you need to know. Okay. And next year we get a little more into how it comes from that. But some of you guys might want to look at some graphs and figure out why these come out the way they do. All right, but the derivative of sine x is cosine x. All right.
Well, that makes sense because the tangent at any point is the cosine.
Yeah. Oh, you're right. That does make sense.
And why does that? Why?
Oh.
Tangent at any point. That's true. Yeah, it's just.
What's the
Okay, you weren't here yesterday? Okay, d over dx is just another way to say do the derivative. It's a derivative. Okay.
So you got the d on the top and the d on the bottom.
Another way to write that would just be if f of x equals sine x, then f prime of x equals cosine x. Okay.
F prime of x is related to
Alright, the derivative of cosine x is negative sine x.
Why is that one negative?
It's the way it works out.
Oh, that's really...
Well, remember that the derivative is another way to say what? The slope of a tangent, right? So if you look at the graphs of sine and cosine, if you look at the graph of a cosine function, maybe we should just do that real quick since you guys are asking about it. So let's look at it real quick. Cosine looks like this, right? Okay, so look at the slopes here in the beginning. These slopes are what? Negative, right? Okay. If we look at a sine graph, these slopes in the beginning are positive, and then they turn negative. Okay, so and these slopes are negative, and then they turn positive. That's part of why. But it's kind of actually interesting that if you take all the slopes at every point of a sine graph and you graph those values, you get the cosine graph. It's actually pretty interesting. Yeah. 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 Antiderivative or integral. Yeah, we might look at a little bit of that, but that's more for next year. Yeah, so we got a couple more here I want to give you. The derivative of, what else do we need now? Tangent x is secant squared x. And the derivative of secant x is secant x tangent x. Don't forget the C on secant x, so you don't forget. Yeah.
That's funny.
Okay, so yeah. Now you don't. Yeah, these have to be memorized. I mean, you don't need to do it today. You can refer to your notes for now, but for before test time, you just got to memorize these four. Okay.
When you mean test time, do you mean files?
No, you're gonna have a test on this stuff. Probably either end of this week or early next week. We still got to do quotient rule. We're not going to do that today. All right, so we got these 4 trig functions, derivatives. Okay, yes, Ken.
So when you wrote f of x, f prime of x,
Yeah.
the owner step and would that be negative prime?
If you did f double prime, yeah. If you went another step over here and did f double prime of x, and that's a good. I'm glad you asked that. That's a good question because you can keep doing derivatives. that would be the derivative of cosine, which would be negative sine of x. And then let's take that one step further, actually. I'm glad you did that. Because there is a pattern there. So what about f triple prime of x? Well, the derivative of derivative of sine is cosine, and we have the negative in front. That just stays there.
So then the next one would be positive sign.
1, 2, 3, 4.
Negative cosine squared.
So now
Sine x.
the derivative of cosine is negative sine, but there's another negative, so that would be positive sine x, and then that would just repeat. Okay. So this we're back to here, and that would keep repeating. So it's a good pattern to actually kind of memorize.
So do right there.
Well,
Wait, the derivative of secant x is secant x times tan x?
yeah. Okay, now we got to do something called a whoa.
Whoa.
Oh yeah, okay. Let's actually do this. So let me get rid of this here first. So here's an example using some trig. All right. We have find an equation of a tangent line to f of x equals 3 cosine x at x equals pi over 2. And let me erase that for a sec. Give you the answer. Okay, so this is what you were doing yesterday, part of that worksheet. Equation of tangent line, you need two things. You need slope and point. We only have an x. So the first thing I want to do is get my y. Plug the x into the original here. So y is going to be 3 cosine pi over 2. And you all know what cosine pi over 2 is.
Yeah, that's relevant.
No, that's it's 90 degrees, first of all. But
So far you get it wrong.
It's relevant.
cosine
Zero, yeah, that is.
of 90 degrees is 0. Okay? So we have the point pi over 2, 0. Alright, that's our point. Now we got to get the slope. And to do that, we do what? F prime, so we do the derivative. So f prime of x equals, now when you have a coefficient with a trig function, that's multiplying, alright? That's not by itself, that's not 3 plus cosine x. If it was that, it would just drop out. But when it's 3 times cosine x, that coefficient just stays, alright? So we're going to keep the coefficient, and the derivative of cosine is,
You get negative. You get negative 3.
yeah, negative sine x, right? And it's, then you would just take the negative and put it in front. So negative 3 sine x. Okay? And now we actually got to know what that is, so we need to plug in x, negative 3 sine pi over 2. And you know sine pi over 2 is 1, positive 1. So this equals negative 3. So that's your slope. And now you just do what we did yesterday, write this point slope point. So y minus 0, you don't need to write that. I'm just going to write it because okay. Just to make sure you have it clear, equals the slope times x minus pi over 2 in this case. Okay?
Would you need to continue and simplify that?
If it's a multiple choice, you probably need to. If it's not multiple choice, you can leave it like that.
So, to simplify that, would it just be y equals negative 3x plus 3 pi over 2?
Yeah, that's so that, you can simplify. Y equals negative 3x plus 3 pi over 2. Yeah. Okay. That's what is that? The equation of?
Tangent line.
That is the equation of the tangent line to this curve at this point. Okay? Alright. I'm actually going to break this up.
Do you have a worksheet again?
Let me stop that and do part 2 in a sec.